Hi guys, this is Miss Eisencraft going over the law of sines, some notes to help you with your assignment. So if we first start with what the law of sines is, it's just a relationship between the sine of an angle and its side. So you can set up a proportion and find missing side lengths and angles in any triangle, including non-right triangles. So let's start by labeling the angles with capital letters A, B, and C. This is just random. And then across from angle A, we're going to call this side length A. Across from angle B, we'll call this side length B. And across from angle C, side length C. And here's what law of sines says. Law of sines says that if you took the sine of angle A over A, it would be equal to the sine of angle B over B. So you could use this to find an angle measurement or a missing side length if you knew 3 of the 4 things. This is also true for the last angle and its side. Sine of angle C over C. So any of these can be written as, any of these proportions can be set up equal to each other. So when can you use this, or what do you need to have in order to use this? Well, this is good for any triangle. You don't have to have a right triangle. It does work for right triangles, but it can be any triangle. And here's what you need to know. You must have an angle and its opposite side. Okay, so that's a must. And then there is, if you see that you have an angle and its opposite side, you also need one more side or angle. So let's just draw a couple triangles here. Let's draw. So let's say that we had this angle, 40, let's say it was just 48 degrees. And we knew this was side length of 12. So right away, this is good news. I have an angle and its opposite side. I would need one more piece of information. So maybe I would have another side like this one. Let's say it was 16. Then I could use law of sines. What I wouldn't know here would be this angle here. I could help find angle B. I also could use it if I had, let's say, this is 40 degrees. Let's say this was 15 this time. And then let's say I knew this was 35 degrees. And then I didn't know this side. So I could use it, a law of sines here, because I have an angle and its opposite side, and then another angle measurement here. So I could use it to find x. All right, let's just truck along and do some examples. The examples I'm going to do in this video are all where we are trying to find missing sides. So let's start with this first one. It says, find the length of side C. So finding the length of side C is this guy right here. So I need to look for an angle, any angle on here, and an opposite side that is known. I see right away that I have side, I have angle A and its opposite side. Good news. Now I'm trying to find side length C, so I'm going to use angle C and side length C. So I'm going to use this proportion and then this proportion. One way to think about it is in a proportion, You have 4 pieces of information and only one should be unknown. So right here I have 3 known pieces of information and 1 unknown piece of information. So I'm just going to set this up. The sine of 77 degrees over its side, 15, is equal to the sine of 23 degrees over C. And if you remember from middle school, cross products, when you have a proportion or 2 ratios set equal to each other, their cross products are equal. So I know that 15 times the sine of 23 has to equal C times the sine of 77. So instead of writing all that out, I know C has to equal 15 times the sine of 23 divided by the sine of 77. Okay, here, if you're using whatever type of calculator you're using, you need to make sure you total this before you divide by sine of 77. So I'm going to hit 15 times the sine of 23. I'm going to push enter on my calculator, and I'm going to keep that answer, divide it by sine of 77. Make sure your calculator is in degrees. And it looks like side C, I will round it off to the nearest tenth, is 6.0. And there's no unit. And that looks reasonable. It is a shorter side. Okay. Okay, moving along. The town surveyor here on this next one has to stake the lot of lot markers for a new public park besides an existing building lot. The engineering park gave the sketch below. How much chain link fence will be needed to enclose the entire park? So it looks like we have side C, but we're going to need to find A and B. So just a multi-step. So we're first looking for a angle and its opposite side. I see that right here with C, angle C and its opposite side. And then let's just start with A. We'll then try to find A first. So first, let's find A. So I'm going to use sine of 68 degrees over 46. That equals sine of 47 over A. Using cross products, I know A is equal to 46 times the sine of 47 divided by sine of 68. Okay, so I'm going to 46 times sine of 47. Enter, divided by sine of 68. I got 36.3 feet. Meters, just kidding. Okay, now I'm going to go ahead and erase this. Now that I've found A, I need to now find B. So B, again, I'm going to use this one because I didn't round it. So I'm going to use that as my known sine proportion, my known ratio. Sine of angle 68 over 46 is equal to, now I need to find B. So I'm going to use angle B that's given in side B, which is what we're trying to find. 65 degrees over B. So using cross products, B is equal to 46 times the sine of 65, all divided by the sine of 68. Sure you total that top part up. 46 times sine of 65 divided by sine of 68. 44.96, so that is about 45 meters. Okay, so now I've figured out all the sides. Well, I just had to figure out A and B, so I need to add them up together. So the 3 sides together, 36.3 plus 45 plus 46. This is in meters, 36.3. 127 0.3 meters of fencing. Total perimeter. Okay, last one. It's a little bit of a weird application one. Okay, Juan and Romella are standing at the seashore 10 miles apart. Okay, the coastline is a straight line between them. Okay, so I'm going to do Juan and Romella. Juan, Romella, 10 miles apart. Okay. Both can see a ship, the same one, in the water. The angle between the coastline and the line between the ship and Juan is 35 degrees. Okay. So the line, so let's just draw a ship out here. Okay. This right here is the coastline. And the angle between the coastline and the line between the ship and Juan is 35 degrees. So they're giving us this angle measurement. Okay. The angle between the coastline and the line between the ship and Romella is 45 degrees. So that is this piece right here. How far is the ship from Juan? So they want to know this length right here. So right now it doesn't look like we can use law of sines because we don't have an angle and an opposite side. But if you remember triangle sum theorem, if you know 2 out of any 3 angles in a triangle, you can easily find the third because there's always 180 degrees in any triangle. So if I know any triangle has 180 degrees, I'll subtract what I have, which is 80 degrees. That leaves me with 100 degrees left. So that was just using triangle sum theorem. Now I can use law of sines because I see I have an angle and its opposite side. So now I don't care about Juan's angle, I care about Romella's because across from Romella is the side length I'm looking for. So I want to then also use these two. So the sine of 45 over x, this time I'm using my unknown first, which is okay, it doesn't matter. Proportions, it doesn't matter which way you write them. Sine of 100 degrees over 10. So x is equal to this cross product, 10 times sine of 45 over sine of 100. 10 times sine of 45 divided by sine of 100. 7.18, so let's just say about 7.2 miles. All right, I'll be back with another video on how to find angles in more multi-step law of sines problems. Thanks for listening.